So we are going to continue our lesson with Theorem 5. So the Theorem 5 makes use of a tangent. So let me explain to you what we mean by a tangent in this case. So if I should have a circle, okay, and I should have a straight line touching the circumference of the circle, just touching the circumference. This is what we call a tangent. Okay? So if I have a circle and then I have a straight line touching the circumference, if I have a circle and I have a straight line touching the circumference, these are all tangents. Okay? Now, in the case where I have a circle and I have a straight line passing through, this is not a tangent. No, this is not a tangent because this doesn't touch the circumference of the circle. So let's go to the theorem itself. If I have a circle and I have a tangent which is touching the circumference of the circle. Very good. Now, if I have a chord which is also touching the tangent, okay, and the circumference at this point, okay, they all meet at this point. And the angle created here is this angle theta. So this is saying that the angle between a chord, this is a chord, and a tangent at the end of the chord, which is this angle theta. So the angle between a chord and then a tangent at the end of the chord, at the end of this chord, this angle is equal to the angle the chord, this chord, subtends at the circumference of the circle. So theta is equal to theta. Let me go again. I'm saying that if I have a chord and then I have a tangent, the angle between the end of this chord and this tangent, which is this angle theta, okay? This angle theta is equal to the angle this chord subtends at the circumference of the circle. So assuming PTS is a tangent, and then RT is a chord and they meet at T, okay? And then we have PQ, PTSR. Let me put V here. So assuming we have PTS being a tangent and then RT being a chord. Now we are saying that the angle between this chord and this tangent, which is this angle theta, is equal to the angle this chord RT subtends to the circumference at V. So we are saying this angle is equal to this angle. So let me write down the theorem for you. The theorem says that the angle between a chord and a tangent at the end of the chord, at the end of the chord is equal to the angle the chord subtends at the circumference of the circle. So this theorem is a little bit some way for students, but it's very simple. We are saying we have a tangent. A tangent is a straight line touching the circumference of the circle. And you could see BTS is a tangent and it is touching the circumference at T. Now, if RT is also a chord, so it means they are meeting at this point, and we are saying the angle between this chord and this tangent, which is this angle theta, is equal to the angle this chord subtends at the circumference of the circle. Again, The angle between this chord VT and this tangent is also the angle alpha. Okay? Now, if this angle alpha and this chord VT, okay, subtends this angle at the circumference, it means this angle is also what? Alpha. Because the angle subtended by the angle between a chord and a tangent, okay, which is this angle, is equal to the angle this chord subtends at the circumference of the circle. And now from here, if this is beta, if this angle is beta, we can say sum of angles on a straight line sum up to what? 180. Alpha plus beta plus theta is equal to 180, which is sum of angles on a straight line, or alpha plus beta plus theta is equal to 180. Sum of the interior angles of a triangle sum up to what? 180 degrees. So you can either use the sum of angles on a straight line or the interior angles of a triangle adding up to 180 degrees.